The AH-64 Apache is the world's most lethal multi-role attack helicopter, yet the Pentagon has spent decades failing to build its successor. We're stuck in an engineering paradox where the very high-speed tilt-rotor performance everyone wants actively erodes the hover stability and low-speed precision a gunship needs to survive. That raises a brutal question. Can we really outrun physics with next-gen designs? Or is the Apache, with all its 1970s roots, quietly irreplaceable in the drone age? At its core, the Apache is a machine built around one specific kind of violence: slow, methodical killing inside the direst slice of the battlefield. It isn't designed to sprint across continents or win air shows. It's designed to hug terrain, mask behind ridgelines, and live inside the envelope where small arms, man-pads, and chaos overlap. Its real superpower is the ability to pause the fight on its own terms. Creep forward at treetop height, pop up just long enough to lock and fire, then disappear again. Everything else, from the way the rotor disc is sized to the way the gun is slaved to the pilot's helmet, serves that core mission of controlled, lethal hover. Now set that against what the future has been promising for 20+ years. The RH-66 Comanche was the first big attempt to push beyond the Apache paradigm. Stealthy, compact, composite, with internal weapons and a focus on low observability rather than brute survivability. It died, not because the idea was stupid, but because the trade space became ugly. Cost, complexity, and strategic environment shifting towards cheaper sensors and missiles. Later, Future Vertical Lift tried to reset the board. Concepts like Bell's V-280 tiltrotor and Sikorsky's Raider X family promised Apache-class firepower welded to radically higher speed. They were technically fascinating, but the deeper the designs went, the more obvious the paradox became. The more you optimize an airframe for flying like a turboprop, the more you drift away from what the Apache actually does in combat. But the real shock to attack helicopters didn't come from tiltrotors. It came from drones. $1,000 loitering munitions and home-built FPV kamikaze platforms, destroying armor and artillery in real time. Quadcopters were spotting everything. Loitering drones were riding data links straight into vehicles' weak points. If you fly an Apache in 2026, the way you flew it in 2003, you are absolutely a dead man in a hot sky. The sensor-to-shooter loop is too fast, too cheap, and too democratized. But that's only half the picture, because the Pentagon keeps upgrading the Apache. They're turning them into nodes in a wider kill web. Instead of relying purely on their own mast-mounted sensors and TABS NPVs to find targets, they're increasingly fed data from UAVs, ground networks, other aircraft, and even satellites. Small drones, loitering munitions, and cheap ISR platforms go fast, soak up the initial risk, and map the battle space. The Apache follows as a heavy, precise hammer, using terrain and timing to minimize exposure. Persistent ISR drones can sit over target zones for hours at altitudes and geometries that would be suicidal for a crewed platform. Swarms can probe air defenses, force the enemy to switch on radars, and expose firing signatures. All of that information can be piped back into the Apache's cockpit and its network, letting pilots choose when and where to unmask for seconds at a time, rather than minutes. In that kind of fight, the helicopter's value isn't just that it carries missiles. It's that it carries a human brain with immediate authority to make lethal decisions at the edge of the fight, connected to everything. Which brings us back to the speed question. If drones are doing deep reconnaissance and first contact, do you really need your attack platform to be a 250-knot tiltrotor? High-speed concepts absolutely have value for getting into theater and repositioning across a wide front, especially in a Pacific or large theater scenario. But once they arrive in the weapons engagement zone, they are subject to the same physics as everyone else. At some point, something has to slow down enough to build a firing solution and assure it isn't killing the wrong thing. That's where all those exotic designs quietly start behaving more like helicopters and less like jets. And that's where the Apache's design choices still make sense. The drone age is forcing helicopters to give up certain roles rather than vanish. The missions most at risk are wide area scouting and loiter until you see something patterns in highly defended airspace. Drones are simply better at that. Cheaper, expendable, persistent, and politically easier to lose. However, helicopters remain extremely hard to replace in roles where you need a big weapons load, complex identification, bad weather performance, or nuanced rules of engagement. So, where does that leave the idea of an Apache replacement? Any serious successor has to live in 3 worlds at once. It needs enough speed and range to stay relevant at theater scale, enough low-speed control authority to function as a stable gun and sensor platform in the worst fight regimes, and enough connectivity and autonomy to orchestrate or cooperate with drones rather than compete with them. So when you ask whether the Apache is irreplaceable, the honest answer is not forever. At some point, a mix of unmanned systems, long-range fires, and possibly a very different kind of gunship could take over its role. For now, the Apache survives in its tension between what we want future air power to look like and what the laws of aerodynamics and combat reality will actually tolerate.